Okay, this is chapter 25, lecture number 3. We're going to talk about net present value and internal rate of return. This is page 1266 through 1274. We're going to talk about present value concepts. We're going to talk about net present value, average, actually we don't need those, sorry. And then we're going to talk about internal rate of return. Okay, so first of all, there's a part of this chapter, this very beginning part where we talk about present values, that I am going to go through on this lecture. But my recommendation is that you go watch the 2 prior videos I made about time value money. Technically, the only one you have to watch for this chapter is present value. However, I find that most students struggle with present value unless they understand. If they don't understand future value, it's hard to understand present value because future value is kind of the easier one to wrap your brain around. But technically speaking, the only one that applies to this chapter of the videos I've recorded so far is the one that talks about the present value and how present value works. So I'm gonna, the part you'll see, I'll go quickly through this part because I have a whole separate video just on this. So if you feel like that's too quick or you don't understand it, please go watch that. As always, you can ask me, email me questions too. So effectively, I'm on page 1267. Present values, we're talking about if I know the value of something in the future, how can I put a value on that today? And most of us know how compound interest works, and effectively I'm doing that in reverse. All right, if I promise you $10,000 5 years from now, what is the value of that today if I could grow it at a rate of 10% or whatever the number is? That's called the discount rate or an interest rate, whatever that rate is. So I'm just going kind of in reverse. So 1267 says the present value of an amount. So it says if you were given the choice to receive $1 now or $1 3 years from now, you should prefer to receive $1 now. Why? Because you can invest it and earn interest for 3 years. We know it's only $1, but still, it's worth more. So if I invest $1 for 3 years at a rate of 12%, that ends up being 1 point. And you can see how they do it. They take $1 times 1.12 and then 1.12 times 1.12 and so on and so forth to get 1.404 at the end of 3 years. So that's a future value, really. That's a compounding. It's a future value factor. We're doing the same thing, but we're doing this in the opposite direction. So if I have a value in the future that I want to discount back to its present value, I just do the opposite. So if I was looking at this and I said, what's the value today of 1.404 3 years from now, $1.40, 1.404, what's the value at a discount rate of 12%? I would take that number divided by 1.12 and then divided by 1.12 again, divided by 1.12 again to get back to its present amount. However, there's an easier way to do that. And that is that if I use a table. Okay, so the table at the bottom of 1267, and I've made one here to pretty much mirror it, just to kind of show it to you in case you didn't see it or can't see it on the bottom of 1267. This is a present value table. So how this would work, so if I know that my value is 1.404 3 years from now, this would be known as my future value. Okay, so 3 years from now at a rate of 12%, I know that's going to be the value of it. How do I find the present value? Well, I can do what I said. I can divide that number by 1.1 at a rate of 12%. Sorry, I need to know that interest rate. Rate is 12%, and the term is 3 years. Term in years is 3. All important things. 12% interest rate. What's its present value? Well, what I can do, like I said, is I can take this 1.404 divided by 1.12, take that number again, divided by 1.12, and take that number again, divided by 1.12. Notice I did it 3 times, 1, 2, 3 years, to get back to the present value of $1. That's one method of doing this, and that's kind of the easiest way to see it. But what you can also use is these tables. That's what these tables are built for. So this over here is the number of years or periods that I'm dealing with, and this is the discount rate or interest rate that I'm dealing with. So in this case, the interest rate is 12%, so I'm going to use this column. Okay, the term is 3 years, so here's my 3 years, so 0.712. And how I use that is all I need to do is take my future value times my 0.712, and there will be some rounding because this numbers actually extend much beyond this, but it should come out to roughly $1. And as you can see, there is some rounding, 0.99965. Okay, but it is roughly $1. I actually built these without rounding, so if I took the 1.404 times my actual number should come out to exactly $1, 0.712, because this number is really longer than that to get my present value. Okay, so that's the present value of a single amount. The next thing the chapter talks about is the present value of an annuity. So in the same way that I can do this for one single amount, if I'm talking about $1.404 in 3 years from now, I can do the same thing if I say, well, what about if I'm going to pay you $1 per year every year for the next 3 years instead? All that changes is that, well, what would I have to do? Well, this is kind of outside the book here, but let's say that's the case. Let's say I want to know the value of $1 that I pay you every year for the next 3 years, and I want to know its present value. Well, the $1 that I'm going to receive 3 years from now, I already found that, right? It'd be the $1 times the 0.712. But I also need the one that I get paid in year 2, so I need $1 times 0.797. I also need the $1 times 0.893, and I would add all those together. So let me show you. If I was going to receive, rather than this being I'm looking for the present value still, because that's never still what I'm looking for. If instead of this being a future value, this would be called a payment of $1, and this is per year, and an interest rate of 3 years. I'm sorry, interest rate of 12%, and let's do 5 years this time. To find the present value, all I would need to do is take $1 times year 1. That would be the present value of my first payment in year 1. And then $1 times 0.797, and there's some rounding going on here, so why they look a little different. $1 times 0.797, $1 times 0.712, $1 times 0.636, $1 times, sorry, I'll make these equal to what I've got over there. $1 times 0.636 and $1 times 0.567. To get my total present value, I would simply add all those together. So my present value of $1 being paid every year regularly for the next 5 years is $3.60, discounted back to its present value. And all I've done is, in this case, what I've shown you is I've just done them individually. Instead of, using the other table, which we'll talk about here in just a second, I've just said, okay, $1 discounted back 1 year, and $1 discounted back 2 years at rate 12%, $1 discounted back 3 years at a rate 12%, 4 years, and so on and so forth, all the way back. To save us time and to make this a little easier, what we call a regular payment at regular intervals, by definition, a regular payment at regular intervals is called an annuity. So they build us a table, and that's an annuity table. It looks like this. Now, this table is not very complicated to build. I don't know if you can see my formula up here, but all I did to build this table was basically sum everything from this table. So what I want you to notice is if I sum, actually I don't need to sum it, this is already summed 3.605. That's the number I got here, again, rounding, but that's the number I got here. So all they've done is add everything. This one is just that plus the year 3 one, plus the year 4 one. So we'll show you. If I highlight this 15% one down to year 7, my total is 4.160. So if I go to the annuity table and look at 15% for 7 years, my total should be 4.16, and it is. Okay. So what do we use these for? I use the present value of a single annuity if I'm talking about $1 amount and I want to find the present value of it. Okay. I use the present value of an annuity table if I'm talking about regular payments like cash inflows in the future. So for example, if I said I had a project that was bringing in $50,000 a year for the next 10 years, I'd use the annuity table because it's just faster to use. I will also show you a function in Excel to do this. So again, there is that present value video if this wasn't detailed enough for you. I know I'm going kind of quickly. All right. And actually, this kind of feels like I just made a second present value video, but that's okay. I'll stop there for now, and I will start the next video with the net present value method on page 1269.